Hello guys, I'm Shreyas A. I'm an educator at an academy. You can follow me on the Learning app as well. You can follow my set of courses in the Learning app as well. So this is a lesson about the petroleum based gaseous fuels. So please do rate it, review it and recommend it. And please do follow us on our YouTube channel, that is the Unacademy Engineering Curriculum Group YouTube channel. Thank you. So guys, let's begin with the course Elements of Mechanical Engineering. I have given my intro already. My name is Shreyas A. I'm a BE Mechanical Engineering student. You can follow me on the Unacademy user platform mentioned over here. So the energy resources is the energy resources the course will be doing, and the lessons will be pertaining to this topic itself. So the target audience for this slide will be engineering students, general audience who are interested in science related topics, people who are interested in environmental resources, people interested in knowing the involvement of natural resources. The learning outcomes of this slide will be, you guys will come to know petroleum based gaseous fuels, in that particularly detailing about the natural gas, liquefied petroleum gas, producer gas, blast furnace gas and the coke oven gas. So let's start with the lesson petroleum based gaseous fuels. So before that, let's have a quote. Motivation is the fuel necessary to keep the human engine running. So petroleum based gaseous fuels, they are fuels which are burned in the gaseous state. They are used for their heat or utilized for their power production purposes. They are used in domestic and commercial sector. They are heavy volatile, so they react to the gases in the atmosphere and create hazardous effects. They are commercially very costlier. The availability depends upon the area and the environment, and harmful effects such as air pollution and water pollution are given out by these petroleum based gaseous fuels. So you can see here the emissions out of the gaseous fuel plants. So this is the total range of how the whole petroleum products is used. So natural gas is a hydrocarbon, which means it is made up of compounds of hydrogen and carbon. The simplest hydrocarbon is the methane, which is made up of one carbon atom and 4 hydrogen atoms. It can be found by itself or with its association with oil. It is both colorless and odorless. Mainly methane, but other carbons also include such as ethane, propane and butane. So you can see the natural gas over here. So this is actually a natural gas refinery plant. So water, oil, sulfur, carbon dioxide and nitrogen are also other impurities which may be mixed with the gas when it comes out of the ground. These impurities are removed before the natural gas are to be delivered. They are measured in a varieties of ways, but the most prominent way is the gigajoule, which signifies around 1 billion joules. So what are the sources of natural gas? Natural gas is a fossil fuel, which means it originates from the remains of the plants and animals that lived many a million years ago. These animals were burned and exposed to heat as a result of being highly compressed underneath thousands of meters of soil and rock. These forces transformed once the living organisms into gas. So this is how the natural gas is obtained, and it is given into the power productions. And you can see the seals here, the gas rich shale or the oil shale. So let's move on to LPG, which is abbreviated as liquefied petroleum gas. It's a mixture of hydrocarbon gases which is used as a fuel in heating appliances as well as in vehicles, as well as they are increasingly replacing the chlorofluorocarbons as an aerosol propellant and as a refrigerant to reduce damage to the ozone layer. It is prepared by wet natural gases and gases. It is used as a motor fuel, as a refrigerant and as a cooking fuel. So you can see the LPG gases over here. This is what the day-to-day appliances which you use in a kitchen is called the LPG gas. So this is the LPG gas refinery unit. So let's move on to producer gas. It is a mixture of flammable gases and non-flammable gases made by the partial combustion of carbonaceous substances, usually coal, in an atmosphere of air and steam. So it is a combustible mixture of nitrogen, carbon monoxide and hydrogen, which is generated by passing air with steam over burning coke or coal in a furnace, and which is used as a fuel. So producer gas, it has low heating value, but it can be manufactured with relatively simple equipment. It is used as a fuel in large industrial functions. So the composition of producer gas is as follows. It composes of around carbon monoxide of around 20 to 30%, hydrogen around 11 to 20%, carbon dioxide around 4 to 6%, nitrogen around 46 to 45%, and methane around 0 to 3%. The uses of these gases are, they are used in furnaces, as fuel in furnaces, and as a source of hydrogen for the synthesis in fertilizers. So this is what the primary gas you get. You can see the primary gas, and this is the various methods of distillation by which the producer gas is obtained. So manufacturing of producer gas, so the first thing will be the fuel. It can be made from practically any fuel. So you can take it as wood waste, peat, coals of all ranks or cokes. And the nature of fuel, if it is a high volatile bituminous coal, it gives a richer gas containing small proportions of methane. If it's a tar vapor, then it also enriches the gas when it is used hot. And if it's coke, then it gives a gas free of tar vapor. So you can see it is a producer gas refinery unit. So manufacturing of producer gas, let's continue with it. Depending on the operating temperature, the low temperature favors high production of carbon dioxide, whereas the high temperature favors high production of the carbon monoxide. On the effect of steam, depending on the water in the coal feed or steam in air blast, it increases the proportion of hydrogen and carbon monoxide in the gas. If the steam is not added, there are chances of clinker formation. So what are the impurities in producer gas? The impurities in producer gas are as follows: steam, tar, dust, sulfur and ammonia. Steam, it lowers the flame temperature. Tar, it increases the flame temperature. Dust, it would foul and choke the gas mains. Sulfur, it can cause corrosion and pollution. And ammonia, it can cause endothermic water gas reaction. So let's move on into the blast furnace gas. It is a byproduct of the blast furnaces that is generated when the iron ore is reduced with coke to metallic iron. So let's have a note about the composition of the blast furnace gases. Carbon dioxide is around 23 to 26%. Hydrogen is around 2 to 4.5%. Carbon dioxide is around 12 to 16%. Nitrogen is around 51 to 57%. Oxygen is around 0.2 to 0.5%, whereas almost nil percentage of hydrogen sulfide as well as ammonia. So you can see the blast furnace gas refinery unit here. So this is the blast furnace gas which is being expelled out. So what are the properties and uses of blast furnace gas? Properties: it is a very poisonous gas due to the presence of carbon monoxide, and blast furnace gas pipes and vessels should be leak proof, or else it may lead to harmful reactions. Under some conditions, the mixture of gas and air forms an explosive mixture which explodes when coming in contact with any source of fire. So what are the uses? They are used in boilers and in foundry ovens. So this is a boiler. You guys can see this is an image depicting the presentation of a boiler. This is an image depicting the presentation of a foundry oven. So let's move on to our last gas, namely the coke oven gas. It is produced during high temperature carbonization of coal. It is the most important fuel in an integrated steel plant. It is a byproduct coke when the evolved coke oven gas leaves the coke oven chambers at high temperatures approaching 2000 degrees Fahrenheit. This hot gas is immediately quenched by direct contact with a spray of aqueous liquor. The resulting cooled gas is water saturated and has a temperature of 170 degrees Fahrenheit. This gas is collected in the coke oven battery gas collecting main. The composition of the coke oven gas constitutes of carbon monoxide around 7.5 to 9%, hydrogen around 55 to 55%, carbon dioxide around 2 to 5%, nitrogen around 2 to 3%, oxygen around 0.3 to 0.6%, hydrogen sulfide around 0.2 to 0.3%, ammonia around 0.2 to 0.5%, and methane around 24 to 26%. So this is a coke oven gas refinery unit. So what are the factors affecting composition of the coke oven gas? The effect of temperature. With increase in temperature of carbonization, the hydrogen content of the coke oven gas, it increases because of the cracking of hydrocarbons. With the effect of time, with increase in time of carbonization at a given temperature, the hydrogen and the hydrocarbon content decreases, resulting in the greatly reduced calorific value of the gas. So thank you guys. Any questions? Please drop those in the comments box below. You can find me at my Unacademy user platform, which is mentioned over in this URL. And please do rate this course, review this course, and recommend this lesson or slide if you have liked the presentation. And please do follow me on my Unacademy user platform, which is mentioned over in this URL. Thank you guys for your wonderful time. Have a good day.